Hi, welcome to the Dummy Programmer. So today we have a easy question to solve. Thankfully, it's called a happy number. So what it says is that write an algorithm to determine if a number n is happy. And what is a happy number? A happy number is such that starting with any positive integer, replace the number by the sum of the square of its digits. Okay, and repeat the process until the number equals 1. Or it loops endlessly in a cycle which does not include 1. Okay, those numbers for which this process ends in 1 are happy. Okay, the output is supposed to be a boolean, true if it's a happy number, false if it's not a happy number. If you were confused by the question, there's a very nice explanation here. So if n is equal to 19, you keep iteratively squaring and summing its digits, okay, until you either get 1. So in this case, for 19, it went through 4 iterations and it ended in 1, right? If it ends in 1, it's a happy number. If it does not end in 1, if it enters a loop, an endless loop where you keep recycling the same numbers again and again, then it's not a happy number. Okay, there are only 2 possibilities here. So it's an interesting question, and you can actually, you can solve it very easily using a dictionary, right? Because you can just, for every iteration, whatever is the output, you keep it in the dictionary, and you check if you have whichever is the output of one iteration, whether it is already there in the dictionary. And if it is already there, that means you've entered a loop, and it's not a happy number, right? And if you come across 1, then yes, it's a happy number. But that uses space, extra space, right? I think the optimal solution in this case can be done without extra space. If you remember the last question on linked list, I think we did, right? Where we had to detect a loop. And how did we detect a loop? We were actually using fast and slow pointers, right? Because every time you have a cyclic structure in your code, if you put 2 different pointers which pace differently, right? One moves twice as fast as the other one. They're going to meet at some point while they're iterating the loop. Okay, the same thing can be done here. So you can basically solve this with no extra space, just using 2 pointers. And this is an approach to keep in mind for other questions on Leetcode. Okay, because ideally you don't have to solve every question on Leetcode, right? But you have to know the strategies, the common strategies that you can use across say 20 or 30 questions. So in this case, we are going to use the same strategy. So every time you think of loops, where you have to detect whether there is a loop or not, think of pointers, fast and slow pointers. Okay, so it's a easy question, it's not very difficult. So let's first create a helper function which actually does this job, where given a number, it squares the digits and sums it and returns to you. Okay, because we are going to use it iteratively, so it's best to create a function out of it. Let's see. Sum squares. I mean, you can give it a better name, but I'll go with this. Okay, number int, and it returns int. Okay, and this is not going to be mutable because we are using Swift. So let's just do this, and then we have to declare a sum property and basically return the sum. Okay, and what is the stopping criteria? The stopping criteria is when, so what we are basically essentially doing in this case is, right, let's say you give it 19, right? So it is going to keep stripping away digits and squaring them and adding it to the sum. Okay, so if you get, say, in this case you get 19, right? So it's going to remove all the digits one by one, and it's going to square it and add it to this sum property. Okay, and eventually you're going to be left with 0 because all the digits are processed. So that's what we're doing here. So while num is not equal to 0, we are going to take out a digit. So let's call it digit, and then we do num %10. So when you do %10, the rightmost digit is going to be removed and it's going to come here. So then what do we do? Then num is equal to num divided by 10 because we have to remove this digit from num because it's already been processed, right? And it's going to, we are going to process the rest of the digits in num. Okay. And then we have to obviously square in sum, which is, I mean, you can use the POW or SQRT functions, but you have to then typecast the data types. So I don't like doing that. So this is what I do. And we keep iterating this and it's going to return the sum. Okay. Now we need to declare 2 pointers, right? So you have your slow pointer, which is equal to n. And then you have fast pointer, which is equal to sum squares of n. Okay. So if you think of it in terms of a track, they are placed, slow is placed at the start and fast is placed at the next. I don't know what is the next thing in track. Okay, think of it as a linked list, right? So if slow is put in the head pointer, fast is put to the next of the head pointer. Okay. And now we're going to move it forward until either of two things happen. Either fast is pointing to 1 or slow and fast become equal. Okay, that means there is a loop. So what we do is fast is not equal to 1 and slow is not equal to fast. Okay, fast is equal to 1, that means it's a happy number, or if slow is equal to fast, it's not a happy number. Okay, in either of those conditions, we break out. Achha, how do we move this forward, right? Slow is going to be sum squares of slow. Okay, it's going to move 1 step forward, but fast is going to move 2 steps forward. They're differently paced. That's why it's called fast and slow pointer. They're placed differently. They're placed 1 node apart, and then they start moving forward at different paces. Okay, so fast is going to become sum squares. Okay, this is 1 step and then another step. So 2 steps forward it is going to take. Okay, and what is going to happen once we break out of this, we have to say whether it's a happy number or not. How do we say that? Fast is equal to 1. That's it. This is the solution. So let's see, if you get an integer here and slow is set to that integer, fast is set to the next. So if slow will be 19, fast is going to be 82. Okay, and then we move them forward until either of two things happen. Either fast becomes 1 or slow becomes equal to fast. Okay, and we move both of them forward at different paces. Slow moves one number forward, 1 iteration forward. Fast moves 2 iterations forward. Okay, and then once we break out of it, we have to check whether it's a happy number or not. And how do we check that? If fast becomes equal to 1, then it's a happy number. Okay, let's run it and see. Yes, it worked. It worked really fast, actually. 0 milliseconds. I think this is the best solution for this problem. That's it for this video. If you like it, please like it, share with your friends, subscribe to the channel. Thank you for watching. See you in the next video. Bye-bye.